Sets. A set is a collection of well-defined objects or things. The objects are called members or elements. Sets can be presented by describing, listing, set builder notation, and diagrammatically on the number line or Venn diagram. A universal set is a set which contains all the elements under discussion, denoted by that E. Operations on sets. Intersection of sets is the set of elements which are common or belong to both set A and set B, denoted by that N. So you can present the intersection of sets by showing that region. That is the region where you have elements which are common between A and B. So that is our A intersection B. Then union of sets. The union of sets is the set of elements whose elements are found in both set A and set B, denoted by that U. So this is the region where you have elements which are found both in set A and in set B. But it's not always that they will have an intersection. Sometimes they can be separate. And that is known as disjoint sets. So that is our A union B. Then we have the complement of a set. This is the set of elements which do not belong to a given set, so it is denoted by that. A union B complement is that region which is shaded, so that is showing the elements which do not belong to A and B. Let's look at some examples. Question 1. The diagram below shows sets A and B. List the sets A complement union B and A complement intersection B complement. So we'll take it step by step. We'll start with the first one, A complement union B. So we are looking at those elements which do not belong to set A, that is A complement. We have 3, 5, 6, and 7. Union, we have set B which has elements 2, 3, and 4. So we are looking for the union. It means we combine. Our final answer will be 2, 3, 4, 5, 6, and 7. Then we have A complement intersection B complement. We are looking at those elements which do not belong to set A, which are 3, 5, 6, and 7. And B complement has elements 1, 5, 6, and 7. 6, 7, and 8. So those are the elements which do not belong to set B. So we are looking for the intersection. Our answer is 5, 6, and 7. So those are the elements which do not belong to set A and set B. We have 5, 6, and 7. We go to the next question. Question 2 is saying, given that E is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So all those are the elements under discussion. Set A has elements 2, 3, 4, 5, and 6. Set B has elements 1, 3, 5, 7, and 9. And set C has elements 2, 5, 7, and 11. The question is saying, illustrate this information in the Venn diagram below. Illustrate this information in the Venn diagram below. So we'll take it step by step. Before we illustrate, we have to make sure that we identify or take note of the element which is found in all the 3 sets. So if you look at those elements, you find that 5 is common, which is in A, in B, and in C. So when you are given a Venn diagram like that, this is the region which is representing the common element between all the 3 sets. That is the region which is common between A and B only. This is the region which is common between A and C, and this is the region between B and C. So what we are going to do, we'll take it step by step. We'll start with the region where we have the common element in all the 3 sets. So 5 is common between A, B, and C, so we'll put it there. Then we have A intersection B. Since 5 has already been represented there, 3 will be in that region. Then we have A intersection C. What is common between A and C is 2 and 5. Our 2 will come there. Then we have B intersection C. What is common between B and C? We have 5 and 7. So our 7 will come there. So after placing all the elements in the intersections, then start completing each of the sets. So set A has elements 2, 3, 4, 5, and 6. whatever has remained will come there. Then set B has elements 1, 3, 5, 7, and 9. Whatever has remained will come there. We have set C. What has remained will come there. But this is not complete. We have to go back to the elements under discussion. Whatever has remained will go in the complement of A, B, and C. That is how our Venn diagram will look like. Part 2. List A intersection B union C. So we are going to check which elements are found in A and also found in B. We have 3 and 5. Union, which elements are found in set C. We have 2, 5, 7, and 11. So we are looking for the union. It means combine them. So our answer will be 2, 3, 5, 7, and 11. Just because 5 is appearing twice doesn't mean you write it twice. You just write it once because 5 is 5. We go to the next question. Question 3 is saying, given that E, all the elements under discussion, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. P, we have factors of 20. Q is the set of multiples of 4. And R is 2, 6, 12, 18, and 20. Illustrate this information in the diagram below. Illustrate this information in the Venn diagram below. Before we do that, we have to list the factors of 20. Now, the factors of 20 are those numbers which you can divide into 20 without leaving a remainder. So we have 1, 2, 4, 5, 10, and 20. But 1 and 5 are not in the elements under discussion. We don't have a 1 here and we don't have a 5. So we are going to leave out 1 and 5 because they are not in the universal set. So the set P we are going to consider will have elements 2, 4, 10, and 20. Then we have Q, which are multiples of 4. Those numbers which are divisible by 4. 4 can go into those numbers without leaving a remainder, but they should be in the universal set. So we have 4, 8, 12, 16, and 20. Then R has already been given. So we are going to take it step by step, just like the way we did in question 2. We'll start with the intersection of all the 3 sets. What is common between P, Q, and R is 20. So we'll place our 20 there. Then we have P intersection Q. There's a 4 which is common. We have P intersection R. We have a 2 which is common, and Q intersection R has a 12 which is common. So we'll place them like that. Whatever has remained in set P will be placed there. This is the region P only, and that is the region Q only. So we have 8 and 16. R only, we have 6 and 18. But this is not complete. We have to go back to our universal set. Whatever has remained will have to be put in the complement of P, Q, and R, which is outside the sets. We continue. List the elements of the set P union Q complement union R. So we are going to look at which elements are found outside the combination of P and Q. So we'll take it step by step. P union Q is that set, that is the region, but they are saying complement, meaning combine P and Q, but those elements which are found outside. So it's 6, 14, and 18. Now, since we have 6, 14, and 18, they are saying union R. So elements in R are 2, 6, 12, 18, and 20. Since we are looking for the union, we are going to combine all of them. So answer will be 2, 6, 12, 14, 18, and 20. We go to the next question. Question 4. Given that E is equal to X is such that, this means such that, X is such that, X is less or equals to 10, X is a member of natural numbers. Natural numbers are counting numbers. And the set P is equal to prime numbers in E, Q is equals to even numbers in E, and R is equals to factors of 6. Illustrate this information in the Venn diagram below. So we'll take it step by step. First, we'll list the natural numbers. Natural numbers are counting numbers. They start from 1. So our E will have elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our set P prime numbers are those numbers where only 1 and the number itself are divisible. Only 1 and the number itself can go into that number without leaving a remainder. So the first prime number is 2. So we'll pick the prime numbers from the universal set, which is giving us 2, 3, 5, and 7. 9 is not a prime number because 3 times 3 will give us a 9. Q is equals to even numbers in E. Even numbers are those numbers which are divisible by 2. 2 can go into those numbers without leaving a remainder. So we have 2, 4, 6, 8, and 10. So R is equal to factors of 6. Those are numbers which are divisible by 6. They can go into 6 without leaving a remainder. So we have 1, 2, 3, and 6. So the question is saying, illustrate this information in a Venn diagram. Like what we did in the other previous questions, we'll have to first fill in the intersection of all the three sets. What is common between P, Q, and R is 2. So we'll put our 2 there. Then what is common between P and R only is 3. What is common between Q and R? We have a 6. There's no common element between P and Q. So when you are given a question, it's not always that this place will have to be filled or that one. You just pick the way the question has been given. If there's nothing common, you leave it. Then we'll complete each of the sets. Set P will be completed. What has remained is 5 and 7. Set Q, what has remained is 4, 8, and 10. Set R, what has remained here is a 1. Then we have to go back to our universal set. Do we have an element which has remained? Yes, which is a 9. You put it in the complement of P, Q, and R. It doesn't belong to P, Q, and R, so it will be in that region. Part 2. List the elements of P union R in brackets complement intersection Q. So we are looking at those elements which are found in P and R but outside. So P and R outside is giving us 4, 8, 9, and 10. So we have 4, 8, 9, and 10. Intersection Q. Q has elements 2, 4, 6, 8, 10. What is common there? You'll find that we have 4, 8, and 10. That is your answer. We go to question 5. Question 5 is saying, the Venn diagram below shows the sets A and B. Using set notation, describe the shaded region. When you look at this shaded region, it is outside A, but in B. So it is the region A complement intersection B. We go to question 6. Question 6 is saying, in a group of 30 pupils, all play either netball or volleyball. 23 pupils play netball and 19 play volleyball. Complete the Venn diagram below to illustrate this information. So we are going to take it step by step. So we are going to first say, let X represent pupils who play both netball and volleyball. So X will be our intersection. So our N, which is netball intersection volleyball, will be equal to X. So this region will represent our X. Now, if this is the intersection, it means that this region is netball only. X are those pupils who played both netball and volleyball. This region is representing the pupils who played netball only, and this region represented those who played volleyball only. So to get this region, you have to subtract the total number of pupils who played netball minus the intersection. We'll do the same even for that region. We'll say the total number of pupils who played volleyball minus the intersection. So we'll say 23 minus X and 19 minus X. But when we add 23 minus X plus 19 minus X, we are supposed to get the total number of pupils, which is 30. So let's do that. We are going to say 23 minus X plus 19 minus X is equal to 30. So if you add 23 minus X plus 19 minus X is equals to 30, you find that negative X and X will give us a 0. 23 plus 19 will give us a 42. So we'll remain with a 42 minus X, which is equals to 30. We'll transpose this 42 to the right. It will become a negative. So we'll say negative x is equals to 30 minus 42. Integers are positive and negative numbers including 0. When the signs are different, we'll subtract and put the sign of the larger number. So our negative x will be equals to negative 12. Multiply the whole equation by a negative 1. Our x will be equals to a positive 12. So what we are going to do is to replace. Where there's x, we are going to substitute a 12. So if we subtract 23 minus 12, we'll get an 11. We'll replace our 12 there. And if we subtract 19 minus 12, we'll get a 7. So our Venn diagram will look like that. So when you add 11 plus 12 plus 7, you're supposed to get a 30. If you add 11 plus 12, you get a 23. Plus 7 will give us a 30, representing the number of pupils. Part 2. How many pupils played one game only? One game only, we have 11 who played netball only and 7 who played volleyball only. So the number of pupils who played one game only was 18. As simple as that.